Okay, we have here today a pretty interesting looking integral from the UNSW Integration Bee 2020. This one was problem 13. I have here the integral from 0 to 1 of the arc sine square root of x dx. And when I was doing this, I feel like maybe I was missing a shortcut or something. Let me know if you had a better way to do this, but I kind of just did the most straightforward thing and went for a u substitution. So what I'm going to do to start, I'm going to make this whole thing my u. So let's just say u equals arc sine square root of x. But then what I can do is solve for x. So just with the inverse, I can write this like square root of x is equal to sine of u. And then squaring this, we have x equals sine squared of u. Then from here, we'll take a derivative. So I get my dx here on the left. Derivative of this is going to be 2 sine u. Then with the chain rule, we get a cos u du. But this here is exactly the double angle formula for sine. So I can actually just rewrite this whole thing as sine of 2u du. So we'll go ahead with the substitution. So first we'll do, let's plug a 1 in for x. Arc sine of 1 is going to be pi over 2. Then plugging in 0, arc sine of 0 is just 0. Then again, this whole thing here is going to be our u. And then for our dx, we're just going to have sine 2u du. But with this, we're in good shape to do integration by parts. I'm just going to clean up the board and we'll do the DI method. Okay, so over here to the right, we've set up our integration by parts using the DI method or tabular integration. And what I want to do is differentiate u. Usually want to differentiate the polynomial because that's going to reduce. So then let's just see what happens when I differentiate here. So derivative of u is just 1. Differentiate one more time. Derivative of 1, 0. Then here we just need to integrate over here. Integral of sine 2u is going to give me minus cos 2u, and then we need to bring a 2 out. And then doing it one more time, integral of this is going to be sine 2u, bring out another 2, and now we have a 4 here. But because we have this 0 here in the last row, so we're not going to have to integrate anything here, we can just take our solution here on the diagonals. Minus times minus plus, I'm going to go out of order, and we're going to take this term first. So we're going to have plus sine 2u over 4, and then this one we have minus u cosine 2u over 2. And we just need to evaluate this thing from 0 to pi over 2. So let's just do this carefully now, plugging in pi over 2. So when we plug in pi over 2 here, we're going to end up with sine of pi, but sine of pi is just 0 for this first term. Then here in our u, we'll have a pi over 2. Cosine 2 times pi over 2, so we're going to have cosine of pi. That's going to give me a minus 1 over this 2 here. Then next we'll evaluate at 0. So sine of 0 is just 0. We don't care about that. Plugging in a 0 here, we have a 0. And we don't really care what that is. That's going to be 1/2, but it doesn't really matter, right? Because what's going to happen is this whole piece is just 0. We have a 0 here, so it ends up I just need to multiply minus 1/2 times minus pi over 2. Doing that gives me my final solution of just pi over 4. Okay, pretty nice problem with integration by parts. Thanks everyone for watching. Have a good day.